Welcome to the VHDL Design and Modeling of Digital Systems course, Concurrent Statements. Concurrent statements exist within architectures. The order in which the concurrent statements are placed within an architecture is irrelevant because each concurrent statement is executed simultaneously at the same time as every other concurrent statement. The concurrent statements we're going to look at today are signal assignments, conditional signal assignments like when else and with select, and also we're going to look at the process briefly here. Now, there are also other types of concurrent statements such as block statement, concurrent procedure call, concurrent assertion, component instantiations, and the generate statement, but we're going to cover those quite a bit later. The base syntax for a signal assignment is shown here. An optional label followed by the signal name identifier, less than symbol, equal symbol, followed by an optional delay mechanism. We'll talk more about that later, and also waveform, and we'll talk about that as well. The delay mechanism allows us to model some real-world physical effects, such as propagation delay through a gate or propagation delay of a signal through a trace. The syntax for the delay mechanism is either transport or inertial, with an optional reject expression time for inertial. The transport option is used to model pure delay of one signal relative to another. The inertial option is used to model the effects of mass, capacitance, or inductance. Since the energy content of each of these qualities cannot change quickly, i.e. they have inertia, we can model their resistance to change by rejecting short pulses or being slow to change. The syntax for the waveform is value expression optionally after time expression, comma, and other value expressions after time expressions, or the keyword unaffected. The waveform allows us to specify how the signal changes over time. If multiple after clauses are used, each succeeding time expression must be greater than the previous one. The unaffected keyword allows us to specify that a signal does not change, but it is specific to the VHDL 2008 specification. Here's an example of some signal assignments. The first one is just A is assigned with the contents of B. The second one is A is set to B after 5 nanoseconds, C after 10 nanoseconds, and D after 15 nanoseconds. Or A is unaffected, and so on and so forth. The transport and inertial we'll demonstrate in the subsequent slides. Here's an example of a design file. The first two lines are the entity statement. There's no inputs or outputs since this is basically a example. The architecture statement, some signals are defined, clock, delayed clock, transport, delayed clock, and inertial delayed clock. Now if you take a look at each of those lines, the first line is clock is equal to not clock after 10 nanoseconds. This basically generates a clock with a period of 20 nanoseconds. Basically as my stimulus so that we can take a look and see what's going on. Delayed clock is assigned with the implicit delay, the implicit signal of clock tick delayed, and delayed by 1 nanosecond. The transport delayed clock is assigned with transport clock after 1 nanosecond, and the inertial delayed clock is inertial clock after 1 nanosecond. Here's a screenshot of ModelSim running the previous code. You can see the clock signal delayed, or every 10 nanoseconds the value of clock is inverted. If you take a look at delayed clock, transport delayed clock, and inertial delayed clock, you'll see that they're all delayed by the same 1 nanosecond. If I were to have said that the inertial delayed clock was not delayed by 1 nanosecond, but was delayed by, say, 15 nanoseconds, it would not change at all, because it's not a pure transport delay. It's waiting for the signal basically to go stable before it does its change. Next, we're going to look at the two conditional signal assignments, the when-else signal assignment and the with-select signal assignment. The when-else signal assignment syntax is basically this: the optional label followed by the signal name identifier, followed by less than equals delay mechanism and waveform, just as we had our basic signal assignment as before, but followed by when condition. The condition is necessarily a Boolean, followed by else statements, else waveform, when condition. You can have a variable number of those, and if none of those conditions are met, there is the default final else waveform statement. This statement allows us to conditionally assign a signal to different waveforms based on different conditions. Here are a few examples. Hit, stand, or fold is assigned with hit me if car total is less than 17, else I fold if car total is greater than 21, else I'll stand. Obviously he's playing blackjack. Destination is assigned with source 0 if selector equals 0, source 1 if selector is equal to 1, source 2 if selector is equal to 2. If all those conditions are not met, then destination is assigned with source 3. Counter is counter plus 1 when rising edge clock. Basically this is a one-line concurrent statement which provides us with an incrementing counter on the rising edge of clock. Here's the syntax for with select signal assignment. Optional label with expression. An expression would be like selector in the previous example. Select, and then signal name equals, and then delay mechanism, waveform with choices, one or more. This statement allows us to conditionally assign a signal value to different waveforms based on different values of a particular selector expression. Here's an example. With selector select, and destination is assigned to source 0 when the value of selector is 0, source 1 when the value of selector is 1, so on and so forth, or source 3 when value of selector doesn't comply with any of the previous conditions. The with select is very similar to the when else, except that you notice that if you're doing things like muxes where your conditions are selector equals 1, selector equals 2, and so forth, that this is probably a cleaner syntax to use. Process syntax is as follows. Process label followed by the keyword process, parenthesis sensitivity list is, then you can have local variables and constants defined, begin, and within a process are sequential statements. Now while the process itself is a concurrent statement, the contents of a process are executed as sequential statements, and we'll cover processes in detail during session 5. Here's an example of a process as created by Emacs. The comments aren't necessary to the language, obviously, but Emacs allows us to add them. Sequential process, which is the label of the process. The keyword process sensitivity list contains one signal, clock. And if rising edge of clock, then we check to see if reset is equal to 1. If it is, we set preset or present state to the idle. Otherwise, we set present state is equal to next state. You'll notice this syntax will look familiar, or at least when we cover processes in session 5. This is a sequential process, not just that it has sequential statements within it, but is a sequential process as opposed to a combinatorial process.